All right, so 9-6. We're going a little bit off of the solving quadratics. So we're no longer finding the x-intercept for our solution. What we're doing instead, as you can tell from the warm-up, and as I mentioned, we are looking at systems. But our systems now are not just going to be two straight lines like they were back in chapter 5. We're going to see other types of graphs as well. And specifically, we're going to see a parabola and a straight line and find where they cross. So that's what we're looking at, okay? Is a parabola and a line and finding those points where they're going to cross each other. Those are our solutions to the systems. Okay? Talk person next to you, how many different numbers of solutions could we have if I'm crossing a parabola and a line? 2. What are my possible number of answers? Okay, so how many possible answers could I have? 2. I could have 2. Could I have more than 2? Can't have more than 2, right? 2 would be if it crosses like that, right? The 2 places where it crosses, that's what we're talking about today. Could I have anything other than 2? Okay, I could have 1 and 0. 0 would be something like that, right? Where they just don't cross each other. What would have to be true for it to be 1? Okay, so it could either go straight up. It would have to be straight up and down. Otherwise, eventually it will hit it. Or it would have to touch just at one point like that. So it is possible to have one solution. We won't see that as often, but it is possible. Most of the time, we're going to get either 2 or none. Okay, so that's what we're looking at today. How we're going to do that, we're going to have a couple different methods. One is by looking at the graph, which is the easiest method, right? If we look at the graph, we can just tell where they cross. Right? What it's going to look like on Big Ideas is they're going to give you the 2 equations, and then they're going to give you 4 graphs that you have to choose which one is correct, and then it'll tell you the solutions there. Right? To pick which graphs are correct, all I want you to do is I want you to concentrate on the linear equation and pick out which of those 4 graphs has the correct linear equation. What can you tell me right now about this linear equation, that graph of that line? What can you tell me for sure that will help us pick out the right one? Cool?
The 5.
The 5 is what? Okay, Owen? He said he forgot, so it's all you. Yeah, 5 is the y-intercept. So I know in this graph, it's going to cross at 5. So I know that. What else do I know? The slope is 2. So from there, from that intercept, I'm going up 2 over 1. So it's going to look something like that. We just have to be able to pick out the right graph based off of that. And then once you pick out that right set of graphs, we can just look at, all right, what points do they cross? I'm not concerned about those. I think they'll do fine on them. All right, just picking out the right graph and then seeing where they cross. Well, we're going to spend most of our time concentrating on substitution and elimination. We can use substitution and elimination, even though we're looking at quadratics, we can still use those 2 methods, just like we did with linear systems. So let's take a look at an example of how we're going to go about that. Okay, so here's our first system. Make sure we have copy down. The good thing about today is just about all of the time, I think there's only one question in the homework that's not like this. both of your equations are going to be solved for y right away, which is great. That really helps us because we don't have to rearrange anything. Everything's just going to be solved for y, which is nice. We're going to start by using substitution. Remember substitution, as we said in the warm-up, as you remember, you got to solve for a variable. We already solved for a y here. Since these are both equal to y, these are equal to each other, right? Basically, all I'm doing is I'm taking this and I'm substituting in for y. So if you have two equations and they're both equal to y, set them equal to each other. That's negative 2x plus 3 is equal to x squared plus x minus 1. Again, if they're both equal to y, then they're equal to each other. So we set them equal to each other. Once we're here, once we've substituted that, we can solve this now. We can take this, get everything to one side, and make it equal 0, just like we've been doing from quadratics. Because right now, this, once we get everything together, is going to be like what we've been doing the whole chapter 9, which is solving quadratic equations. Okay, so we're going to get everything over to one side. So I'm going to add the 2x over. I'm going to subtract the 3. I'm going to move everything over that one side, make it equal 0. It's going to be 0 is equal to x squared plus 3x minus 4. And then I can solve that. Once I get that all equal to 0, I get that in that standard form. Now I can factor it. That's x plus 4, x minus 1, which means my two answers here, negative 4 and positive 1. Those are my x values. So unfortunately, I'm not done yet, right? I'm looking for ordered pairs where it's going to cross, because I'm not just looking at x-intercepts anymore. I'm looking at, here's a quadratic equation, here's a linear. I want the two ordered pairs where they cross. So I got to take both of these one at a time. I got to plug it back in and get the y value. So my answers are going to be negative 4 comma something and 1 comma something. Okay, we got to get ordered pairs out of it. Why don't you go ahead and plug negative 4 into probably the bottom one, it's going to be easier. And then a 1 into it and see what we get. I'm plugging in negative 4, what do I get?
11.
11. Thank you. If I plug in a 1, what do I get? 1. So those are the two ordered pairs where these two graphs are going to cross. Negative 4 comma 11 and 1. Okay. Any questions on our substitution? Okay. Substitution we can do every single time. Okay. We just set the two things equal to each other and get everything over to one side. Okay. All right. Let's look at elimination. Okay, so same idea. It's going to be a different system, but same idea. And if we're going to use elimination, remember we want stuff to eliminate. We want stuff to cancel out at least one of the variables. And the variable, the easiest variable to eliminate here is the y. Because they're both y's, all we have to do is make one of them negative, and that's going to cancel out. So remember, we need everything to line up before we can do elimination. So what I'm going to do is I'm going to take that negative 3x, I'm going to shift it over so it's under that negative 3x. That negative 8, I'm going to shift it over. So I'm going to rewrite that just so it's right underneath minus 8. Yeah. Yeah. So I'm going to line that up so that it's right underneath what it looks like. Okay. So then to make it eliminate, remember you need one positive, one negative. So I'm going to multiply all the bottom ones by negative. I'm going to change all the signs. I'm going to make that negative, positive, positive. So I change every single sign on that bottom one. So now I can add straight down, right? Because I know the y and the negative y are going to cancel each other out. We said in the warm up, we went over that one, y minus y is 0. So those cancel out. The negative 3x, the positive 3x, those are going to cancel out too. When I add straight down, I'm left with an x squared plus 6. And if we don't have that bx term, we can solve just using square roots. So what we would do is we would subtract 6 from both sides. X squared is equal to negative 6. What's my answer? No solution. Why is it no solution? Can't take square root of a negative. So we get here, we see the square root of a negative. We say, all right, no solution. If that was a positive 6, then we could actually take the square root and get our two numbers, plug them back in. All right, just remember, it's always ordered pairs that we're looking for here. Okay, so substitution, you set the two things equal to each other, then get everything over to one side. Elimination works a little bit nicer because you don't have to worry about moving stuff over to one side to make it equal to 0. It's going to automatically equal 0 once you eliminate the y's. Elimination may be a little bit better in terms of that, but either way is going to work. All right, let me give you one to try. See what we can do. So, okay, so there's our system. You can use either substitution or elimination, whichever one you prefer. When we're going to use elimination, you're going to line it up first. We'll have to take a couple minutes. All right, now remember we're looking for ordered pairs at the end. There you go. I talked to somebody about it. What they're doing. take a look. I showed both ways here, at least the start of them. This one's the substitution. All right, substitution. I make the two equal to each other. I get everything over to one side, make it equal 0. I'm left with here. Elimination. If I go to eliminate and I'm always going to make the linear one negative because I don't want to worry about a negative x squared. So I'm going to make this a negative y, this a positive 5x. And when I add straight down, look at what I'm left with. I'm left with the exact same thing. So whether you're using substitution or elimination, we're going to get to that same point where we're factoring. And we get those two x values, we have to plug them back in and get our answers. Okay, so it shouldn't matter which one you use. I know big ideas on the homework, it's going to say specifically use substitution or use elimination. You can feel free to use either one. I don't care as long as you can get the answer, because eventually you're going to get to the same spot. Okay, I don't think so. I think it just says solve the system. Yeah. Okay, and once we get here, right, we factor it. We got x plus 3, x minus 1, which means x is negative 3, and a positive 1. We got to take those numbers, we got to plug them back in. What do we get for our answers? Paul, what did you get?
1 and negative 5, negative 315.
There you go. 1, negative 5, negative 315. Okay, questions on that? Let's do one more, and then we'll call it good.
Let's go.
I'm going to refrain from giving you the one whose answers are 1/3 and negative 2/3, just so you know. Okay. All right. Okay, there you go. You work through it with somebody if you'd like. Do it on your own. Let's solve it. All right, so hopefully we got to here. Right? We took that negative out as a GCF, because we always do that, especially if we're going to try to factor it. But we're left here. Okay, maybe we even took the next step where we multiplied over x squared plus x plus 27, and we're trying to find factors. There's no factors of 27 that are going to add up to 1. That's impossible, right? So what we could do is we could assume that there's no solution, or we could go through quadratic formula and make sure that there's no solution. Remember, to make sure that there's no solution, all you really have to do is that discriminant. B squared minus 4ac. Because if that becomes negative, we know there's no solution. So we can check to make sure there's no solution by doing that. Okay, and if I'm going to do that, I'm going to use the original. I'm not going to do it where I pull the negative out. I'm going to use that original. So b squared, that's going to be a negative 1 squared minus 4 times a times c. That's going to give me 1 and then minus a really big number. So yeah, it's going to be negative. There's going to be no solution. But just keep in mind, if you can't factor it, there's still a quadratic formula. And as much as we don't want to do that after we've solved the system, sometimes we might have to if we can't factor, right? Or we can't just use square root. So just keep that in mind, right? Use all of your methods for solving quadratic solutions. Okay, last thing just to point out, because we will see a question on it. There is a fourth method, which is called approximating the solutions. We're not doing it, okay? That's basically graph it and then guess where it is, and then keep guessing until you get close enough. Right? They're like guessing like 6 different times to see if they can get close. We're not doing that, okay? But you will have a question on the homework that says, what are all of the different possible ways you could do this? And this is one of them, approximate the solution, okay? So that's all you need to know about it. All right, that's it. Go ahead.